Yay. Alright, we are back. Let's see. I don't have a camera on my PC. Yeah, that happens. Really, I didn't know they made PCs without cameras. I thought the problem was too many of them. Cool. Yeah, so welcome to spring and welcome to CSE223. Bunch of things to go over today. I want to spend a little bit of time going over kind of the introductory administrative detail stuff. But then I want to kind of jump into talking about Java and talking about your first assignment. You have a really short Hello World kind of assignment that I'd like you to submit by Wednesday morning. This is just kind of a getting everybody on board kind of thing. And then your first larger programming assignment is due April 16th. So we've got some time for that. But let's kind of hit the ground running here. And so let me bring up Canvas. So be sure to read this. Presumably people already looked at this. But, you know, most of you are in 222 and 224, so you know the drill here, right? This is a remote class. It's not actually an online class. So it's like an in-person class, except we're not in person. But, you know, it's every day at 10 o'clock. And I would like people to be here as much as possible, as opposed to just watching the videos after class. Ideally, right, this would be a very interactive class, and that's really up to, you know, all of you, how interactive you want this to be. So I've got a note in here about trying to stay present, right? This is really hard. I get more and more invitations to, you know, committee meetings and administrative meetings and meetings about meetings and things like this, and yeah, absolutely, you know, if I've got to sit in an hour-long meeting where I have no idea what someone's talking about, I'm going to multitask. I'm going to do other stuff. I cannot sit down for an hour and just listen to somebody talk about, you know, the latest details about Clark's budget or whatever, right? I'm going to do other stuff. That's kind of our nature. As much as possible, though, I would like you to try to spend your time when you're in class, my class or any other class, just doing that, right? It's really challenging. I totally get that. But the more that you can spend your time in here sort of concentrating on what's going on in class, the more you're going to be able to do your assignments and homeworks and so on. And you're going to have to spend that time sooner or later, right? And I think it's a pretty horrible feeling when you've got an assignment due and the first thing you have to do is go back and watch a week worth of videos and try to get out the material. And you're going to fast forward and you're going to try to skip through and so on. If you can spend, you know, as much of the class time as possible on class, it's really going to help you. And yeah, so turning on your cameras can help with that, right? I don't think I can actually look at everybody's camera while I'm sharing my screen, but you know, just being able to see each other and know that you're not, you know, kind of alone in this, I think can help. And then also, you know, asking questions either in chat or on microphone, really thinking about the material as we're going through it and so on, that will all help. Zoom meeting info, presumably everybody here has got this since you're here. Final exam is way off. We don't have to worry about that. Programming assignments will be a little different from the past courses. So I'm going to have you do a single GitLab repository that all your assignments and homeworks are going to go into. So you only have to set this up once. You only have to add me as a reporter once. You only have to confirm once that I have access to it. And then as long as nothing changes on your end, you just keep pushing over your work. So we'll go through details of that. And again, if you need to reach me, best option is either come to office hours or find me on email. My office hours are the same as they were last quarter. And they're posted on the website. And if if those don't work for you, if you work or you have a class at that time or something, let me know and we'll figure something out. All right, so that's the be sure to read me part. Take a quick run through the syllabus. You may have already looked at this. Reminder about this being a remote class as opposed to online. The textbook is, again, it's an open access textbook. It's a free download. I don't recommend printing this. It's huge, but it's a good resource. It's not just, a reprinting of Oracle's documentation. It's actually a textbook somebody, spent time and energy putting together to take you through the idea of object-oriented programming, and Java in particular. I don't use this in a very particular way. I don't, assign homework question 7 from chapter such and such. But it's as good a resource as any. If we were not remote, if we were meeting in person, I have a few bookshelves in my office filled with old Java books. And I always offer students to come by, and if they want to take a couple of books for their own library, they're welcome to take them, right? They're books I saved from the garbage pile years ago. But we're not able to do that right now. But, really any decent Java resource is going to work for you well here. No, don't print the textbook. Write it by hand because you'll learn it better. It's only about 1,000 pages. So, yeah, if you start early. No. Any decent Java book will work. If you want a physical copy of a book, just find something that looks like a good style for you. And Java, the way we're going to learn it and use it in here, hasn't really changed much in quite a while. We're not doing the cutting edge, Java 11 stuff. So textbook is not too super picky. We're going to be working on Java from the command line for the first few weeks. So we'll be using Unix. We'll either be using the Linux server that we've been using every quarter so far, or your own Linux setup, and we'll just be compiling and running from the command line. So we're still going to avoid IDEs for the next few weeks, and then we're going to switch to Eclipse. And I still need to, get a totally clean setup on Dropbox and try different versions of Eclipse and see which one is going to work best for what we're doing. So details will become available later, but for the first few weeks, we'll just stay on the command line. So, and that's a good way to jump into this stuff. I'll let you read the course outcomes yourself. These may or may not mean a whole lot to you at this point, but presumably as we go forward, you'll see more and more of these things that we've done. Grading is probably more interesting to people, so kind of the same breakdown as before. So probably 5 longer programming assignments for a total of 30%. I've got 3 quizzes posted online. I'll try to put more quizzes up before the next few weeks are done. These are just kind of like, touchstone, see how you're doing with concepts. So that's 10%. Your service learning project continues through this quarter and ends, the last week of the school year with a big presentation. So the total SLP component of your grade is 10%. Midterm is 20, and then final exam is 30. I don't think I'm doing ODPs. We'll see. If I find opportunities to start doing ODPs, then I'll add those back in and probably put them together under quizzes or something. But right now, I'm not planning to do any one-day programs. And then the course policies and support services and college-wide policies, those are the same as they are every quarter. So if you've never looked at those, please read those over carefully and ask questions if you have them. But most people here have been taking courses. Yeah, I like the ODPs, but really the ODPs are largely an attempt to, sort of motivate people to work on stuff on a daily basis, right? So we're learning about linked lists, and we're going to have an assignment due in 2 weeks on linked lists, and it's just too much of a tendency for people not to do anything with linked lists until, a week and a half from now. So the ODPs were really kind of a way to sort of help people kind of keep up with stuff throughout the term. and hopefully you've got some habits from that now, and will be successful at doing that yourself. And that's also with an eye towards most people moving to a university next term, so in fall. But we'll see. All right, so additional course policies. Anything I need to say about in here? Um, There's the office hours. There's a 223 Discord. Nobody's claimed first chat yet, as far as I knew, as of yesterday. So, but yeah, there's a Discord room available. If you've done 222, you're good. Hey, you got your acceptance letter to WSU. Awesome, congratulations. Yeah, this is a fun time of year. Um, let's see. Hey, you got yours too. Excellent. Cool. All right, so policies again. I'll mostly defer people to asking me questions in office hours or during class. I'll reply to emails generally once a day, usually in the morning before office hours. You can talk to Discord. You can ping me in Discord. If you tag my name, I'll usually see a notification, but not always. Programming assignments, as usual, make sure you're writing your own code. Okay, whatever you submit has to be your own work. If you decide to look at code elsewhere, just be aware that it's really hard to unsee code. Now, there's a lot of code in the textbook. There's code we'll be going through in class, and there's certainly a lot of code online, right? And I'm not going to say you can never look at that stuff, okay? Because honestly, once you know how to code, a good way to learn about algorithms or concepts is by looking at code. Just be really sure that the code that you're writing to turn in, you're actually writing from your own head, as opposed to copying something that you saw that looks like it works. Generally, no late work. Programming assignments, you can do 24 hours late for a 25% deduction. I don't expect that the issue of setting me up as a reporter and so on hopefully won't be an issue, since it's all the same repository. So just make sure that you've got your stuff submitted on time. If something goes wrong, you can turn it in a little late and you lose some points, but I'll still grade it. Please don't miss the midterm. Please don't miss the final exam. Another change, so I will generally not be fixing programs that are submitted. I'll grade them as they're submitted. This is, again, a sort of transition towards, university experience. So in the past, if you turn in your program and you added a comment at the last minute and the comment had a syntax error in it, and so your program doesn't compile, in the past I would go through, I would fix that, I'd take off a few points, and I'd keep grading. Okay, mostly in this course, I'm going to, compile your code, execute it, and grade it based on what happens. So we'll do that. Programming style counts, keep up the good habit with commenting and indenting, etc., etc. That's pretty much it for additional course policies. Oral exams are not a bad idea. I'm actually pretty seriously considering moving in that direction, and if we're doing online exams in fall, I'll probably be doing oral exams, at least as part of that. And that's I wouldn't find that unenjoyable. I like talking to students about programming and about their questions and so on. But anyway, we don't have to worry about that for now. All right, so the lectures are being recorded, and I'll be posting these on YouTube, and they'll be indexed by topic and date in the usual way, and you can click through on links here. If you have any concerns about that, I don't post, the chat window. I don't post the list of participants. There shouldn't be anything in the videos that identifies individual students. The exception is if you do use your microphone to ask a question, right, your voice will potentially be recorded. So if that's an issue, send me a message and ask me to stop recording while you ask a question, or ask your question in chat, or send me an email and we'll figure something out. Yeah, I am going to record lectures, at least for now. All right, so quick start guide from 224, 222. If you were in those classes, you've seen those. If not, if this is your first class with me, take a look here for information on how to log in, what the Linux server is, what your initial login and password is, and so on and so forth. There's a video version of it. Also, if you've never done Git, or if you haven't done it for this class, there's information in this quick start guide on using Git. And if you're new to Git, there's a quick video on how to get started with GitLab and Git in general. Link to code samples, link to Java documentation. So this is just a quick link to the Oracle documentation, which is kind of, the motherlode of Oracle, but it's huge. But once you know how to navigate this, it's a really good resource. Let's see. I think I allow comments on YouTube videos, like the Odd Nick video that makes it into large. Yeah, I put other stuff in there. And yeah, we have some students in here who did not take 222. People sometimes come in from other schools or other situations, and if they've had appropriate background, I'll let them in to 223. So we get a bunch of students in here, so it's good. All right, so any questions on any of that administrative stuff? Necessary to go through, but not particularly topical. All right, so let me give you a general, yeah, it is Ignore Typo Monday. Let me give you a general notion of 222 versus 223. And the main thing I want to mention here is that, you've heard me say that 222 is probably the most difficult course in the sequence. And in a lot of ways it is. But that's mainly because it picks up speed really quickly, right? 121 is an intro course. It goes into C, in a pretty gentle introduction. And then 224 really just continues 121, and we did a lot of C. We did a lot of Unix from the ground up. And then 222, suddenly we're like writing programs, and we're doing mallocs and dynamic memory and memory leaks and pointers. And it's really kind of like, okay, C, now we're going to use it. So it feels to me like that is for students kind of the steepest learning curve, the fastest, ramp up. And so I call that the hardest course in the sequence. 223, though, is not an easy course, right? It's not like it's just review or something. We're learning, for many of us, new concepts, right? We're going to learn a completely new way to think about programming, which is the idea of object-oriented programming. And this is a fundamental shift. And we go from C to Java because C is not object-oriented, Java is. Now, C and Java look a lot alike. And in fact, you can actually write C code in Java, right? You can take what you've done in C, and for the most part, ignoring pointers, you can write, procedural statements that look like C, and you can compile it and run it, and it'll pretty much work. But Java is a totally different paradigm. It's what we call object-oriented, and it's a fundamentally different way of thinking about how to structure our code and our data. So it's different from 222, but it's still a lot of work, but it's a lot of fun, okay? And I can almost promise you that you will enjoy doing your assignments in 223, in a way that you might not have enjoyed 222. And we get to do bigger assignments in here. We get to work with kind of more real world stuff. We'll do some networking, we'll do some multi-threading, we'll do some game development. Um, and there's a lot of kind of like quick satisfaction, especially when we start working with GUIs and playing in Eclipse. Um, we'll write a few lines of code and things will start popping up on our screen, and that's always fun. And part of the idea of being in an object-oriented language and framework is that we don't have to constantly reinvent the wheel. And in 222 in C, right, we were constantly reinventing the wheel. We created linked lists from the ground up, right? We made a pointer and we made a node and we set the pointer to point to the node, and then we did something else, right? 223, that stuff is all available for us. So if we want a linked list, we'll just grab a linked list from a class library, right? And if we want a stack, we'll just grab a stack, and so on. And we use those things to do other stuff. So 222, we were creating Lego blocks by taking little pieces of plastic and super glue and putting them together. 223, we get to use the Lego blocks to build castles and fortresses and things like that. So it should be a fun class in that sense. All right. So let me give you a really quick Reader's Digest version of C and Java. Oh yeah, the Craggle, right? Yeah, I would never glue Legos. No, I meant like actually creating individual Lego blocks out of like plastic. All right, so really quick. This is always a hopeless endeavor to try to like summarize languages like this. But let me just give you a few points on each of these. So C, one of the main so very old. Right, so C was around in the 70s, Java relatively new. Not like last year, but certainly newer than C. A bigger difference, C is compiled. When you write a C program and you say GCC, you're running a compiler, a program called GCC that reads your C code and turns it into ones and zeros. And those ones and zeros are ingestible by the CPU, by the actual hardware inside your machine. Right? So it's compiling it down to machine code. Java is actually compiled and interpreted. So you compile your Java code into ones and zeros, but those ones and zeros mean nothing to your CPU. It's compiled into an assembly language, a machine language, but not a machine language your CPU understands. It's assembled into machine code for something called the Java Virtual Machine, or the JVM. And the JVM is a program that runs on your CPU, and it interprets the ones and zeros that you get when you compile your Java program. So it's an intermediate layer in between your source code and the actual execution. But the benefit of that is that it's extremely portable, whereas C is CPU specific. So I compile a program on my x86 machine, my laptop, and I get an executable program, a.out, right? If I copy that file to my Raspberry Pi and I say a.out, it's not going to execute, because the ones and zeros that my Pi understands are different from the ones and zeros that my Intel processor understands. On the other hand, if I take a Java program and I compile it and I get my class file, and I move that class file to my Raspberry Pi and I say execute it, it'll still run. And so portability is a big go-to for Java. I don't think all object-oriented languages do that. In particular, C++, which is sort of the first object-oriented language in some way. First popular one. That compiles down to ones and zeros that your CPU understands. But Python is interpreted, so that's portable. So that's good. On the other hand, there's a speed penalty. So because the C code you compile goes straight into ones and zeros that are executed by your CPU, it's very fast, right? In some cases, it's almost as fast as writing directly in assembly language. Java is going to be slower because what you're writing is still interpreted by a little program running in your CPU saying, oh, here's a 1, what does that mean, right? But that speed difference has gotten to be less and less of an issue. So it used to be something like 10x. I mean, when this first came out, you really didn't want to use Java for something where speed was critical. For me personally, the portability is so much of an incentive that I almost always use Java now for any kind of project I'm planning to share with anybody, even though there's a speed hitch. And even some of the speed sensitive stuff that I've done, I still do in Java just because of the benefits of it. One of those benefits is multi-threading. So very easy to write code in Java that says basically I want to do things on like 5 different threads. 5 different processes executing simultaneously, sharing information with one another, working together to do some task. Now you can do that in C. It is not fun. Okay, you'll do that in some of your university level classes. You'll see what I mean. Very I won't say unpleasant, but very tricky to do that in C, right? Very, very easy and painless for the most part to do it in Java. And we'll do some of this. We'll get into this towards the end of the quarter. So that's one of the advantages. But there's a lot of things that we get with our object-oriented mindset over here, right? So networking is going to be relatively painless. Creating graphical interfaces, right, the portability is going to be really key, because if I make a GUI in C that works on my Windows system running on an x86, and I try to run that on a Linux system running on the same hardware, it's probably not going to work. And then if I try to go to a Raspberry Pi, it's probably not going to work there either. If I'm doing this in Java, it's pretty portable. Please don't tell me I need to make the cache. Oh, we'll see. Haunted by Knapsack. No, Knapsack's your friend. Now, we won't be doing knapsack problems in here, but we might drop eggs. All right. Let's see. Where should we go from here? Let's do a really quick run through on Git. All right, so you can organize your code any way that you like. Oh yeah, question: why is it called object-oriented programming? So 40,000-foot view, right? In C, we have this idea of a structure statement, right? So we can have data types like integers and characters and floats, but we can create more complex data types called structs. And so we can make a struct called answer that has an item inventory and a max val and stuff like this, right? In an object-oriented language, we can also create structs that include not just different pieces of data but also pieces of code. So we can have code and data gathered together into kind of an uber structure, and that structure is called an object. So an object is a thing that has both code and data inside it. And so that's the object of object-oriented programming. And that'll make more sense, I think, once we start actually playing with some objects. All right. So you can organize your work for this quarter any way that you like. Okay. But let me just show you kind of an example. So I've just made for myself in some directory a 223 directory. All right. And what I'm going to do is put this thing under git control. So this is the root of my submission directory. Okay. Um, and so git remote add origin git at gitlab.com /Nick Macias. Gotta spell your name right. And let me where'd my window go? Let me do a quick eyeball on the first programming assignment. Programming assignment A. So we'll go through this next, but let me just grab the repository from here. All right, so your Git repository is CSE223 submissions. All right, like that. So let me just go ahead and set this up. All right, hold on. Let me see what the question is here. Oh, we got lots of questions I missed. Let's see. On Git, are we using branches then? No, we don't have to use branches yet. So branches on Git are really when you want multiple versions of the same repository. So you have a master branch, you have a development branch, you have a bug 1 branch, a development 2 branch, and so on. And we don't need to get into those yet. But what we're going to do is we're going to put each project in a separate directory. And so when you update your Git repo, right, it will have all of your projects, all of your directories, and you'll just be working in a different directory for each project. Let's see. I do chuckle occasionally. Don't interpreted languages run faster after the first run? Well, it depends. So sometimes you have what's called like just-in-time compilation, where as a program is being interpreted, there's kind of parts of it that are being translated into machine code that'll actually run on the CPU, and it depends on the language and on how good the interpreter is. And I think Java does some degree of just-in-time compilation, but I have not dug into the internals of the Java virtual machine. That's one of those rainy summer day things to play with. But I have not done that. I don't know if that was a question I missed or not, but yeah, definitely repost. All right, so let's go ahead and make a repository. Oh, it was good. Okay. So CSE223 submissions and put your .git at the end. And then so let's just do an add commit. Starting my repository, git push origin master. All right, so I'm all set. I need to go over to GitLab and make sure that I add myself as a reporter, which I don't have to do, but add yourself as a reporter, and you should be all set. And what I have right now is a repository that can be synchronized on GitLab, and I can make subdirectories under here anytime that I that I had things and push them, they'll be available to be downloaded. So on Canvas, I was looking at PA-A. So it's under homework or programming assignments, and yeah, it's PA-A. All right, so let's talk about this assignment. And again, this is due Wednesday morning. So this is a hello world, okay? It's a 10-point assignment, and it's basically, getting you to well, enter code, you know how to do that, compile it and execute it in Java, and then, push it over to Git in the usual way. So the source code I'm actually giving you, okay, and we'll talk about what this does over the next few weeks. And it'll actually be quite a few weeks before we can explain exactly what each of these words means. But this is, kind of boilerplate hello world. And so let's I don't know if you can actually copy and paste from a PDF today. That kind of changes over time. But let's try this. So you want your file to be called pa0.java. And yeah, it didn't work. Yeah. All right. So here's a Java program. So yeah, a few differences from C right off the top. We don't need to import standard io.h. Okay. Now, as we use other things, we'll need to import them. But a lot of things that we're going to use often, like system out print line, we don't need to import them. Okay. Our main program is going to be declared almost always like this: public static void main string bracket bracket args. And this string bracket bracket is exciting for two reasons. One, this is how we define arrays. And this is saying args is an array. We no longer need argc and argv. Okay, arrays are a real thing in Java. All right, and that's exciting because arrays in C always kind of make our life a little unpleasant. Arrays in Java have a built-in notion of how long they are. So we have real arrays. Two, this word strings are built into Java, so we don't have to do arrays of characters anymore like we do in C. There's actually a data type called a string. All right, so this is a lot more modern. Let's see. Well, yeah, so it does look more complex in some ways than a hello world on C, but well worth it. So yeah, arrays have functions. Well, not really, but they have a length, and we can say array name.length and see what the length is. But strings have lots of functions. So we'll write some sample code with strings after this as kind of our first object. All right, so public is saying that this class is available outside of this file. Class is a keyword. PA0 is the name of the class. Now PA0 is the same as the name of my file. That's important. Okay. Unlike C, we can't just call our files anything we want. The name of the file itself is related to the name of the class you create in the file. So that's different, but usually not a problem. Okay. Public static void main. This is peanut butter and jelly. They always go together. And this makes our main program. It has one argument, which is an array of strings. And then here's the one line of code we want to execute. And instead of saying printf, we say system.out.println. It's kind of long and wordy, but you'll type it a few million times this quarter, you'll get used to it. And then in parentheses, we just put the thing that we want to print, and it's just a quoted string, hello, double quotes as usual, and then our closing curly brackets. All right. So so this program, you know, is in the assignment, and you can just copy it from there. System is capitalized, so everything is case sensitive. And in this case, string has to be capitalized, and system has to be capitalized. If you're looking ahead, the reason is because those are the names of classes. All right, and classes are usually uppercase, and variables usually start with a lowercase, like args or main. Let's see. Yeah, there's a lot of commonality among object-oriented, which is good. All right, so here's my program, and it's just, you know, it's just a file, so I can cat it and so on and so forth. But the assignment says that this should be put in its own directory. Okay, so submit your code as a subdirectory named PA-A in your Git repository. All right, so I kind of messed up already. All right, so what am I going to do? Here's my main repository that I've linked to CSE223 submissions. So I'm going to make dir PA-A, and I'm just going to move my PA0 into PA-A. So now my main directory has my README, and it has my subdirectory for my first assignment. Right, and if I go into PA-A, there's my my Java file. All right, now I can't run this, right? If I try to do this, it's not even set to be executable, and if I change it to be executable, it would give me errors when I tried to run it anyway. So we need to compile this. All right, compile is just the command javac. So javac in the name of the file, that compiles it. All right. If there's no errors, you don't get any output. If there's errors, you will get output. Cool. All right. Now that I've compiled it, I have a new file in my directory, pa0.class. And if I try to look at this, it's mostly binary. Right, so it's understandable by the Java virtual machine, but not necessarily by us. Now there's my string hello, and here's PA0, and here's some directory names. But you know, this stuff here in the beginning doesn't necessarily mean anything to us, but it will mean something to the Java virtual machine. All right, so how do we execute our program? Java space and then the name of the class file. So in this case, it's just Java space PA0. So do that, and our program executes, and it says hello. All right, that's your PA-A. All right, now I want to submit this, right? So I can go ahead and git add, git commit. And this is my working version. Git push origin master. I'm done. Okay. So you should see that it's submitted to, you know, that repository, but it will be a subdirectory, right, under PA-A. Now, if you want to double check this, make yourself a new directory, which is totally empty. Let me see. Git checkout, git at gitlab.com/Nick Macias /CSE223 submissions.git. You have to initialize your repository. And then do your git checkout. Sorry. Git clone. You don't need to initialize it. All right, so do your git clone. Spell your name correctly. And that will pull down your repository, and it will create a subdirectory under your current directory. All right, so forget all the typos, right? When you want to check, just go into a new directory and just say git clone. Get it gitlab.com, your name / CSE223 submissions.git. And now if you go into that directory, you should see your whole directory structure. So there's the README. I can go into PA-A and I can see my code there, and I can still compile. And I can still execute, and that works great. Checkout is for pulling out a branch, so forget that I typed that. But yeah, that's for switching from branch to branch, among other things. But to clone your repository, just do a git clone. Or you can go to gitlab.com and you can go to the repository and you can hit the clone button and say download as a zip or clone it and so on. Either of those work great. All right, so this is the procedure we're going to use. So here's my 223 directory. So, you know, if I want to do PA1, I'll make a PA1, and, you know, I'll add some files there. Git add, git commit, add some meaningful message, git push origin master, and bingo, my PA1 is submitted. All right, so very easy once you got this set up. So the goal for Wednesday is to get this set up. So if you've done 222, 224, you know how to do this. If you haven't done those and you're not sure how to do Git, right, definitely ping me, and I'll accept an email on that also, and we'll get you up to speed. Also, you know, same as I did last year, since this is the first time we're creating this repository, if you want me to confirm before Wednesday that I have access to your repository, send me a note today, okay, and I'll make sure that I can clone your repo. If your user ID on Git has changed, you have to let me know what your new name is, because I'm going to use the same names that you had last time. If you're totally new to this, you have to send me your GitLab ID so that I know how to download. Yeah, do a hack team. Totally. All right, so questions about that? All right, cool. So tomorrow we will start digging into Java itself, and I want to start off with strings and look at strings as objects, and that'll be a kind of good first intro to the notion of object-oriented design. And we'll just keep building this throughout the week. And then after a day or two, we'll be able to talk about the first assignment. PA1 is posted on Canvas. It's due a week from Friday, so you can look at that, and we'll start talking about that in another day or two. All right, cool. Have a good one. I will see you tomorrow. Thanks.